Good evening, everyone. Welcome to the week 12 of Environmental Chemistry problem solving session offered by NPTEL. My name is Manchi Tripathi. I am TA for this course. So in this session, we'll help you solve some exemplary problems which will help you in solving the assignment question as well as the questions which will come in the examinations. So this is the last week of the session of this environmental chemistry semester. So I hope you have gone through all the lectures and understood all the concepts properly. In case if required, we can have some extra sessions. So please do write me if you need some extra sessions. So or if there is any specific problem that you want me to address. So for this week, we'll solve some questions. So the question number 1 is, given the following two half reactions, so these are two half reactions of perchlorate ion and sodium or hypochlorous acid with E naught values for both of them. What is E naught for the half reaction? Representing the oxidation of HOCl to ClO3 minus. So two half reactions are given both for the reductions. Okay, reduction of both the compounds. So the question arises, what is the E naught value for the half reaction in which oxidation of HOCl to ClO3 is carried out? As you can see from the E naught values, E naught value of HOCl reaction is more than the E naught values of ClO3 minus reactions. Okay, so HOCl has more reduction potential, right? So it can be reduced to, it can be oxidized to ClO3 negative. Okay, so E naught values are the, these reactions are there. So what you need to find out is the oxidation of HOCl to ClO3 negative. So please try to solve this question. We'll see the solution in a while. We'll see the solution now. So oxidation of HOCl to ClO3 also means reduction of ClO3 to HOCl. So the first first of all, first reactions will be involved. So from that we got the E naught value as 1.446 volt. By and adding by reversing the second reaction, if we reverse the second reaction, add it to the first one, because we are reversing the reaction, the E naught value will be flipped, because E naught generally represents the reduction potential. Okay, so these values will be flipped to represent the oxidation. That's why we are seeing a minus sign here. When we add both the E naught values, we will get the reaction. Okay, while adding the values, we need to multiply the second equation, and we will just add the values, like we will add both the reactions. Okay, then what will happen? Cl and Cl will be cancelled. Cl chloride and chloride ion will be cancelled. One H plus ion will be reduced, so it will become 5H plus at the reactant side. So like that, H2O will also reduce. It will become 2H2O and at the right hand side. So after doing this process, we will get the values. So as you can see, the E naught, whatever the E naught values we are getting, that will be negative. So that is why it will represent the oxidation. If we will flip the reaction again, then it will represent as reduction of Cl perchlorate ion to HOCl. Okay. So E naught, the sign of E naught values represents either the oxidation is going on or the reduction. Moving towards question number 2. Silver jewelry is usually kept in airtight pouches, okay, and strictly away from rubber bands. If exposed to either of these, it tends to tarnish. Why is it so? So we are keeping a silver jewelry in airtight pouches. We do not want it to be exposed to air or rubber bands. Why? Why this happens? These are the four options. Please take some time and try to find out the answer. The option A is sulfur present in rubber or air oxidizes to silver having zero valency to Ag2S. B is silver forms rust due to moisture. C. Silver has high reducing tendency. D. Carbon dioxide in air dissolved with moisture developed acidic condition on the surface. So these are the four options. Please try to find out which one of them is correct. Well, see the answer. So answer is option A. Sulfur present in rubber or air oxidizes Ag to Ag2S. So that's why a black layer is formed over that. So this is the reaction given. 2Ag plus H2S, which is present in air, it, it transforms to Ag2S plus H2. This is the reaction that undergoes when the tarnish of silver occurs. The tarnish can be removed by allowing the following reaction. How it can be removed? This reaction is used. Now, since the silver is tarnished, so tarnished form is Ag2S. So when it is uh, used with aluminium, it again it again gets converted to silver and the rest of the product. So now we can get proper silver again. Question number 3 is, what is the voltage of a voltaic cell at standard condition based on this reaction? Is the reaction spontaneous as written? So one reaction is given, we need to find out what is the voltage of voltaic cell. Please try to find out the answer of this question. Option A to A, B, C and D are given. We'll see the answer now. Answer is current 0.62 volt and it is a spontaneous reaction. We'll see how. So first of all, we'll write the reactions in the form of two half reactions. When we will combine both the reactions, like these two reactions we can get from standard books, when we will combine both the reactions, so one is oxidation and other is reduction. So that's why the sign of the second reaction, which is written in the form of reduction here, but in the main equation it is in the form of oxidation. So that's why we have to reverse the sign. So while adding both the reaction, we will get 0.62 volt. Since EH naught is positive, this reaction is spontaneous. Moving towards question number 4, select the correct method used for controlling corrosion in metal. So you know that in metal corrosion occurs, especially we see on iron or silver also, as we have seen in the last examples. So corrosion of metal is happening. So which of the following are the methods which are used for controlling the corrosion? Four options are there. First is insulating metal and oxygen, for example paint. B. Applying a potential to avoid a thermodynamically favorable condition for corrosion. Scratching the surface to create active sites for reactions. And using another metal to sacrifice it rather than metal of concern. So more than one option is correct in this, and you have to identify all the options, otherwise marks won't be allotted. We'll see the solution now. So option number A, B and D are correct. First of all, we insulate the metal which is anode in this condition because it is sacrificed, it is removed or corroded, and oxygen which is a cathode. So we apply paint to do that. B is we apply a potential to thermodynamically there are this because the corrosion is thermodynamically favorable reaction, we apply some opposite potential to reduce this favorability. And the option is we use another metal, like we some case we use zinc to coat the metal so that it gets sacrificed and the main metal is saved. So as we see, A, B, D are correct option, and scratching, what will happen by using the third option? Scratching the surface would rather create active sites for reduction that would further enhance the corrosion. So we need to smoothen the surface rather than scratching it. Question number 5 is choose the incorrect statement among the following. Anode is the terminal at which reduction occurs, and at cathode oxidation. B is galvanic cells are the cells requiring external current to induce non-spontaneous reaction, and electrolytic cells are the cells that generate current due to spontaneous reaction. Standard hydrogen electrode has H2 gas at 1 atm with volt as 0 volt. In nature, the presence of other reactions apart from redox reaction like precipitation, acid-base interaction, and complexation don't affect the direction of reaction. Option E is the hydrogen fuel cell generally generates electrical energy due to oxidation of H2 to H2 rather than combustion. Sorry. So please try to answer the following questions. Choose the correct option for this question number 5. We'll see the options in a while. We'll see the solution now. So the option number A, B and D are correct. We have to identify the incorrect, right? So that's what I was thinking. So A, B and D are incorrect. Okay. So C and E are correct as it is. So for option A, at anode oxidation occurs and at cathode reduction occurs. Oxidation is the area in which metal is sacrificed. Okay. B. Galvanic cell produce current flow due to spontaneous reaction, and electrolytic cell require external current to make non-spontaneous reaction. Option D is, in nature, all the reactions occur simultaneously and influence the direction of reaction to a great extent. All type of reaction, not only redox, but other reactions like precipitation and other reactions that were mentioned, all of combustion reaction also, all of these reactions uh, affect the direction of the reaction. Now, question number 6 and 7 are combined. So, the question statement is, nitrification is an important process in the nitrogen cycle. Ammonia formed by the process of ammonification gets oxidized to nitrite and then by nitrate by the process of nitrification. Some bacteria are involved in this process. Some reaction may not be available in standard books, and hence it is required of you to solve the question from the basics of thermodynamics. This is the statement. This is the question number 6. Determine the standard potential for the following nitrification reaction. So first of all, what you need to do, you need to find out two half reactions and their potential, reduction potential. Then this can be solved. If it is not given in the book, then you need to use or employ your basic thermodynamics to find out the E naught values. So please try to solve this question. We'll see the solution in a while. We'll see the solution. So the answer is 460 millivolts. Let's see how. So as we know, Gibbs free energy is equal to minus NEF delta EH. Gibbs free energy is given by the following reaction, like product, Gibbs free energy of the product, Gibbs free energy of the formation of products minus Gibbs free energy of the formation of reactant. This how then change in Gibbs free energy is minus 355.55 kilojoule per mole. So just we have to keep it in the first equation. So delta EH is equal to minus 355.55 divided by Ne. How we are getting the value of Ne? Okay. So number of electrons 8 into Faraday's 96.5. So when you will write two half reactions, you will get the number of electron transferred as 8. So that gives us delta EH is equal to 0.46 volts, which is 460 millivolts. Question number 7 is, okay, the nitrification process usually starts with ammonium ion rather than ammonia. As solved in previous question, what will be the standard potential if ammonium ion is present rather than ammonia? Please solve this question. Answer is 391 millivolts. Same for the first half reaction. We have EH value as 881 millivolts. For the second half reaction, we have reduction potential as 1272 millivolts. By combining, by reversing the first reaction, we get 391 millivolts. Question number 8 is, a metal undergoes the following two half reactions. What potential would be measured if the cell with standard hydrogen electrode was connected to cell containing an electrode made of titanium in a solution of 0.1 molar T2 plus at 25 degrees Celsius? Assume RT by F to be 0.02568. Please try to solve this question. We'll see the solution after that. We'll see the solution. So T3 plus electron is equal to T2 plus. That is the first reaction. We can see the second reaction as well, just, and the third reaction. So third reaction we are getting by rearranging the equations. Then EH is equal to EH naught minus RT upon NF ln Q. Just putting everything in the equation, we get EH as 0.369. What is the value of E for the half reactions? This is the, but we need to find out the value of E, electrode potential for this half cell. Please try to solve this question. We'll see the solution now. Answer is 1.44 volts. From standard books, EH naught for the above reaction is 1.508 volts. EH is equal to EH naught, the same equation that we have seen in previous question. Just put all these values and this gives us EH is equal to 1.44 volts. Question number 10 is the predominance area diagram discussed in lecture 60 implies the different condition at a pH range or PE. The diagram is useful for analyzing the conditions and determining the course of action for the removal of toxic arsenic. Choose correct statement from the given statement. First statement is the spent sludge range as depicted is in oxidizing condition due to applied potential to force a thermodynamically unfeasible reaction. B. Leachate stating in lower P and pH range implies it can travel far distance without changing the concentration as arsenic is prevalent in AS3 plus form, prefers to see dissolved. Co-precipitation of iron solids as FeOH thrice with arsenic allows an easy removal for the same. The linear slope line in speciation suggests no involvement of H plus ions in the redox reduction, and option E is Fe3 plus stays as dissolved for most of the ranges demonstrated. Please find the answer to this question. We'll see the solution. Solution is B and C. So that's all for today. Thank you everyone. In case of any special session required, please do write it to me.